Okay, question 8. A triangle XYZ is called fun if it has the following properties. All right, very encouraging. Angle YXZ equals to 30 degrees, XY equals root 3A, and YZ equals to A, where A is a constant. So, for a given value of A, there are two distinct fun triangles, S and T, where the area of S is greater than the area of T. And it's asking you to find ratio. Okay, so first things first, you sort of want to draw a diagram to sort of visualize what's going on. Yeah. So let's figure out where the two triangles are. So the first way you could get this, let me just draw a rough diagram with 30 degrees here. So root 3a is of course longer than a, right? So maybe this is root 3a and this will be a. So the first triangle will be sort of here, yeah, where y would be here, x will be here, and then no, I don't mean that, because YXZ has to be 30 degrees. So x is in the middle. So x is here, y is here, and then z is here. All right, that's the first possibility. All right, YZ is a, by the way, so that's not a, sorry. So a will be here, my bad. Okay, now where's my second triangle possible? Well, I could sort of rotate this side sort of more outwards, right, sort of clockwise, because I have no restrictions on the angles, up top and down below. Right, I only have restrictions on the 30 degrees. Okay, so if I rotate the A slightly clockwise, like here, to the black spot, so the Z is here now, that's also possible. Yeah, the bigger triangle will be S, this whole black one. Yeah, whereas the orange one will be T. Whereas the orange one will be T. Okay, so now we have to find the ratio, area of S and area of T. Okay, so what can I do? Now let me make this diagram more legible in some sense. Okay, so what can I be doing? How about, because we're trying to find the area, right? So how about we're trying to find the height of this triangle, right? So how do I get the height of that triangle? Well, I know that the height is perpendicular to the base. Yeah, so it's definitely perpendicular here. So what can I do? Sine 30, well, let's call that h, shall we? So let's call that h. Sine 30 equals to opposite over adjacent. Yeah, and we know that sine 30 is 1/2. So 1/2 equals h over root 3a. So h must be root 3 over 2a. Okay, if h is root 3 over 2a, this should resemble a very, very familiar triangle. Yeah, if the height is root 3 over 2a, you know that the triangle is equilateral. Yeah, you could prove that by simply Pythagorasing, and then you could prove that the base is also a. All right, that means that all of these angles are 60 degrees. So this is 60, 60, and 60 up here as well. So that tells you that this angle here must be how many? This angle here must be 30 degrees as well. Yeah, if you look at the angle sum of the triangle of the bigger one. Yeah, the bigger triangle has an angle sum 180 as well. So that must be 30. All right. So that proves that the triangle, the orange triangle, is isosceles. If it's isosceles, this length here is also a. Now we're all set. So what's the ratio area of S to area of T? Well, it must be 2 to 1. Why is that so? Because they have the same height. Yeah, they share the same height, which is that dotted line H that I've drawn. But then the base of S is twice as long as the base of T. Yeah, the orange triangle has the base of length A, whereas the larger triangle has the base of length 2A. Yeah, so the ratio of the bases is exactly the ratio of the area of the triangle. So answer 2 to 1.